Hi everyone, this is Emily from Rev Robotics. One of the things we've noticed in past years for the FTC season is a lot of teams seem to be intimidated by autonomous programming. What we mean by this is that there's a lot of achievable tasks built into autonomous from every game, and it still seems like a lot of teams are afraid to touch autonomous or afraid to code something. This year with Kickoff Concepts, we want to break that fear from you guys. And so we're going to go through some of our basic strategies for creating an autonomous code that is simple and easy to use this season for anyone listening and tuning in. Okay, so we're going to take this ClassBot. We know we want to build a robot sort of similar to this ClassBot to achieve this year's game, which we'll build a little bit later. And so we're going to go through some early steps of how to program with our ClassBot since we know that it's going to be somewhat similar. The first thing we did to create a strategy was we looked at the field and we looked at the autonomous objectives and we decided on a goal. Our goal was to be able to place the preloaded freight onto the level 1 of the Alliance shipping hub and then drive completely into the warehouse. The reason we chose these goals is that we think that any basic robot that's going to be able to play this year's game is going to easily be able to score on level 1 of the Alliance shipping hub and be able to get completely into the warehouse. Once we decided that as the goal, we decided to make some paths. So our first draft of a path, which should be up on the screen now, walks through 3 different paths. You start in the corner nearest to the, or you start in your Red Alliance side of the field on the corner where the Red Alliance and Audience side field walls meet. And then you drive towards the Alliance shipping hub. And then once you do that and place your freight, you're gonna do sort of a turn to correct out and drive into the warehouse. The reason that we want to do this correction is so that we avoid driving over the little triangle ends of each of the barriers into the warehouse, so that we can avoid getting our robot stuck. Now that we've decided on this path, we had to kind of go over and look and make sure that it made sense. One of the things we realized was that if you took this path, you were potentially interfering with your Alliance partner's randomization zone. So instead of crossing through and correcting right there, we decided what we wanted to do is create another path where we go towards the Alliance shipping hub, and then we turn, once we place our freight, we turn back towards the Audience side wall, correct, and then drive into the warehouse. This could give your Alliance partner extra time to read their randomization. It will maybe reduce any potential interference between you and your Alliance partner, and it gives you more time to correct so that you can properly get straight into the warehouse. Now that we've done this pathing, we can go ahead and look at what kind of programming we need. What we did was we took our basic encoder navigation program, which is in our Hello Robot guide. We'll put some links below. If you're a Java user, don't worry. We'll also have some links for y'all, but we're gonna do this in blocks so that it's a little bit easier for everyone. We took this basic code, and one of the things we first looked at was that we originally had a conversion to drive counts per millimeter. The reason for this is that all of our Rev product is in metric, and so we thought that this would be an easier value to go to originally. But since you're working in a field that's in inches, it's a 12-foot field or 144 inches, we decided to convert to drive counts per inch before we went ahead and made our target positions. The next thing we did was we took our encoder reads, so right drive dot current position or left drive dot current position, and we added on the amount of inches we wanted to move. So what this does is we take that 30 inches we want to move, we multiply it by drive counts per inch, which is the amount of counts per inch, and then we add it to our current position. This reduces the need for us to do a stop and reset encoder, and it gives us a little bit more flexibility as we move further along. The next thing we did was we took a basic chunk of code for the robot mode, set mode to run to position. This block of code basically takes your encoder counts and in any command you give it, which is our target position, and drives you to that target position. So now that we have our set right targets and we have a target position, our robot will go to the 30 inches or 15 inches that we've commanded it to go to. Then we chose a set power level to dictate speed, and we created a while loop that said that we wanted to focus on this target until both of the motors were no longer busy running to position. Now that we have that basic code for our first path, we can look at creating a code for all 4 of our paths. So if you look, we've sort of modified our code a little bit and we've made it longer. We have our first path, and then we repeat the same amount of code to get our second path, our third path, and finally our path that runs into the warehouse. The reason we have 4 paths is, I don't think I explained this a little bit earlier on, but the reason we have 4 paths is that we want time to lift our arm up before we approach the Alliance Shipping Hub. If you lift your arm up after that, after you've approached the Alliance Shipping Hub, you risk knocking it over, which we can perhaps show in a later video. Now that we have this, we can go ahead and we can take our robot out to the warehouse, and we're going to do a test run on our field of our code. So let's go ahead and get that up and going. So now that we're out in the warehouse, we're going to just test our code. As we said, we move to the Alliance Shipping Hub, we back, and we correct. We're not going to drive all the way into the warehouse because this robot will flip over doing it. See how simple that was? With just some basic code that you can find accessible in our Hello Robot Guide documentation, which again will be linked below, you can get an autonomous up and running very simply. Obviously, there's some things we left out. We don't know what kind of intake or arm or delivery mechanism we're going to have yet, so all we did is our path for now. When we get later on into our build systems, we'll look at how to create a full-fledged pathing that includes scoring and driving completely into the warehouse. But for now, these basics should get you started to program your own robot, and stay tuned for more information. Don't forget to like and subscribe.